Okay, so as I promised, this is my discussion on special right triangles. And I'm going to discuss with you the difference between the 30-60-90 triangle and the 45-45-90 triangle as special right triangles. The 30-60-90 triangle has 30, 60, and 90 interior angles, in which this is a right triangle because it contains a right angle. The longest side is called the hypotenuse, which is labeled as C, and the side opposite our 30-degree angle is side A, and the side opposite our 60-degree angle is side B. Take note that the longest side is also the side opposite our 90-degree angle. In a 45-45-90 triangle, the base angles are congruent, which are 45 and 45 degrees, and the other angle is 90 degrees. Again, the longest side is the side opposite the largest angle, which is 90 degrees, and the side is called the hypotenuse and labeled as C. And the two other legs are congruent, in which these two legs are opposite sides of the base angles that are congruent, which measures 45 degrees. The sides or the legs are side A or side B. But before we go further, please like and share so that others may also learn. And please don't forget to subscribe my videos for more videos to come. Let's go. So we have here our 30-60-90 triangle theorem. It says here that in a 30-60-90 triangle, the longest side is twice the side opposite the 30-degree angle, and the other side is square root of 3 times the side opposite the 30-degree angle. Okay. So in order for us to understand it better, it's better for us to illustrate the 30-degree angle. So we have here our triangle. Okay. Okay. So we have here our right triangle, and this is our 30 degrees, 30-degree angle, and this is our 60-degree angle. Okay, and this is our 90-degree angle. Now, it says here, the longest side is twice the side. It's twice the side opposite our 30-degree angle. But the question is, how long is our side opposite 30-degree angle? So that we can have the longest side, which is twice the side opposite our twice the side opposite the 30-degree angle. Okay, so we can assign value or length of the side opposite our 30-degree angle as x, so that we can represent also our longest sides as 2 times x. That is our longest side. And the other side is square root of 3 times the side opposite 30 degrees or 30-degree angle. So square root of 3 times the side opposite the 30-degree angle. What is our length of the side opposite our 30-degree angle? It's x, and that's square root of 3. So we have x square root of 3. Okay, so the side opposite the 30-degree angle measures x, and the longest side measures 2x, and the side opposite the 60-degree angle is x square root of 3, or the adjacent side of 30 degrees is x square root of 3. Now, we can verify that. We can verify using our Pythagorean theorem, which is c squared is equal to a squared plus b squared. So this is our Pythagorean theorem. It says here that the square of the longest side is equal to the sum of the squares of its two legs. So we have our longest side is 2x. So I square that. And the other side, we can say that the side opposite our 30-degree angle, which is x, can be the value of a. So we have x squared. And the other side is x square root of 3 squared. And the square of 2x is 4x squared is equal to, okay, that's still a question mark, x squared plus x squared. The square of square root of 3 is 3. So we have times 3. Therefore, we have 4x squared is equal to x squared plus 3x squared. Okay? And then we have 4x squared is equal to 4x squared. So the side length of the triangle are sides of a right triangle. We have x, 2x, and x square root of 3. So I'm going to give you examples on how to make use of this theorem so that you can apply that in your lessons later on. For example, number 1, we have a triangle, okay, in which this is our right angle, our 30 degrees, and our 60 degrees. The side opposite our 30 degrees measures 2 units, and the unknown sides are the hypotenuse and adjacent sides. Okay, so basing from our discussion on the derivation of the length of the sides of this triangle, we have A is equal to X, which is equal to 2. So that is this is our A. This is our A. A is equal to 2. And our B is equal to X square root of 3, which is unknown. And our C is 2x, which is also unknown. However, okay, since our x is already given, side B can have a value or length as 2 square root of 3, since our x is equal to 2, and our C is 2 times 3, which is equal to 6. Therefore, side B, okay, side B could be 2 square root of 3, and side C is 6. So we have here 2 square root of 3, and C is 6. So that's how we use our Pythagorean or our 30, 60, 90 triangle. Number 2, we have another triangle, and this is 30 degrees. This is right angle, and this is our A, our B, and our C, which is equal to 6. Again, we have A, which is unknown, x. Our B is also unknown, x square root of 3. But our C is 2x, which is equal to 6. So from here, from our side C, we can already get our value for x, or we can derive our value for x. So we have 2x is equal to 6. Divide both sides by 2 so that we can retain our variable x. 6 divided by 2 is equal to 3. Therefore, the value of x now is 3, and the value of, or the length of b is 3 square root of 3. So we have here 3 square root of 3, and we have 3 here. Okay? And the last example would be another triangle. Okay? And we have a right angle here. This is our 30 degrees. This is our side A, the side opposite, our angle 30 degrees. Side B, which is equal to 4 units, and side C, which is also unknown. Again, we have A is equal to X, B is equal to 4, no. B is equal to X square root of 3, which is equal to 4, and C is equal to 2X, okay? So we can derive the value of X from the side B, since it has a real value, okay? So from here, we have X square root of 3 equals 4. Again, divide both sides by square root of 3. And we have X is equal to 4 over square root of 3, or by rationalization, we have 4 square root of 3 over 3. So that is our X. So that our C is 2X, and since our X is 4, square root of 3 over 3, then our C, which is 2X, is equal to 2 times 4 square root of 3 over 3, which is equal to 8 square root of 3 over 3. So therefore, our side A is now 4 square root of 3 over 3, and our C is 8 square root of 3 over 3. Okay? So that is how we use our 30, 60, 90 triangle theorem. Whereas in our 45, 45, 90 triangle, it says here, in a 45, 45, 90 triangle, the longest side is the square root of 2 times the side opposite one of its legs. Okay? So if we're going to illustrate that, we have a 45, 45 here, okay, in which the legs are congruent. So if the legs are congruent, then the opposite angles are also congruent. So we have our 90, we have 45 degrees, and we have also our 45 degrees. So these are the legs which are congruent. And this is our hypotenuse, which is the longest side. It says here, okay, in a 45, 45 triangle, the longest side is square root of 2, okay? Square root of 2 times the side opposite one of its legs. But what is the length of side A or leg A, or the side B or leg B? Say we have X and X here. Therefore, our hypotenuse is square root of 2 times X, or X square root of 2. Okay? So that is our side length of a 45, 45, 90 triangle. Okay, so let's have some examples here as an application of 45, 45, 90 triangle. Example, we have here a given triangle. Okay, this is our right angle, our 45, 45 degree angles. And since these are two congruent angles, then the side opposite these angles are also congruent. Suppose our side length here is 2, then find our B, okay, our B and our C. So again, our side A and side B are congruent, and our C is X square root of 2 only. So A is equal to 2, which is equal to X, which is also equal to B, okay? And therefore C is equal to X square root of 2, in which our X is equal to 2. So we have 2 square root of 2. Therefore, our B now, our B, okay, our B would be 2, and our C would be 2 square root of 2. Okay, as easy as that. Number 2, Another triangle. Okay. So we have here right angle, our 45 degrees and our 45 degrees. We have our A, our B, and our C. Our given this time is the side opposite the 90 degrees or the longest side, which is 5 units. So find the value or the length of side A and side B. Find side A and side B. Again, A is equal to X, which is equal to B, and therefore C is equal to X square root of 2, which is equal to 5. So since our unknown is the value of X, then we can make use of our equation here. X square root of 2 equals 5. So from here, we have X square root of 2 equals 5. And we divide both sides by square root of 2. So we can cancel X is equal to 5 square root of 2. Or by rationalization, we have X is equal to 5 square root of 2 over 2. So our value or length of side A and side B would be 5 square root of 2 and 5 square root of 2 over 2. Okay? Last example, we have number 3. Number 3. Another triangle. We have 90 degrees, 45, and 45 degrees. This is our 4 square root of 3, the longest side, our A and our B. Okay, this is our C. So we're going to find our length for side A and length for side B. Again, A is equal to X, B is equal to X, and C is equal to X square root of 3, which is equal to 4 square root of 3 also. Sorry, that's correct. Okay, X square root, this must be X square root of 2, square root of 2. So from here, from this equation, we can find the value of X. So X square root of 2 is equal to 4 square root of 3. Divide both sides by square root of 2. So we have cancel. X is equal to 4 square root of 3 times square root of 2 over 2. Therefore, X is equal to 4 square root of 6 over 2. Okay, so that would be our X. Or this is our 4. Okay, the final answer would be X is equal to 2 square root of 6. So our X now is equal to 2 square root of 6. And the other X inside A is 2 square root of 6. Okay?